Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Jadi hari ini kita akan masuk the last subtopic for chapter 11 iaitu radioactivity lah, or what we call as a radioactive decay process. So what exactly is radioactive decay process? It's a nucleus of a very unstable atoms or molecules breaking apart and emit particles or radiation. Okay, so basically we have a very high energetic, very radioactive, very unstable atoms or molecules. Okay, so in order to become stable, they will emit some of the particles lah. Okay, so normally we have alpha decay, okay, so beta decay and also gamma decay lah. Okay, so this one, this contoh lah, this parent element, okay, dia punya elemen awal dia tu, so very unstable, very radioactive. Okay, so what happen, untuk alpha decay, they will emit, dia akan buang this alpha particles so that they become a stable version of themselves lah. So alpha particles can be known as also as helium lah. 4 to helium di mana mereka akan buang 2 protons and 2 neutrons lah. So in total 4 nucleons to become more stable version of themselves. Okay, so kalau untuk beta decay, so that's why it's called decay. So dorang punya number of nuclide tu berkurang. Okay, decrease in value. So that's why we call as perebutan decay. Okay, and then beta decay pula, they will emit beta particles, or we call as electron or E positive charge, iaitu a positron. Okay, so this one, when we draw E electron kan, E negative charge, so will be E0 negative 1 lah, or either ataupun E1 or 0 lah. Okay, okay, so this one, bila dia dah buang electron or positron, so they become a more stable version of themselves. And then last one is a gamma decay. Okay, so gamma decay, dia tak akan buang apa-apa nucleons. Okay, they just emit a radiation. Okay, so this radiation is mostly harmful lah. Okay, but they then become a stable version of themselves. Okay, right, so this is what we call as a radioactive process lah. Okay, so apa yang kita akan belajar adalah kita akan belajar pasal the decay process tu, what is the calculation involved in the decay process. Okay, so the first one that you have to learn adalah state and use the decay law. Okay, so kita tengoklah apa itu decay law. Okay, so law of radioactive decay cakap for a radioactive source, so must be a radioactive source because the radioactive source yang very unstable and mereka akan buang some of the particles. Okay, so the decay rate, okay, kadar perebutan tu is directly proportional to the number of radioactive nuclei present in the source. Okay, so this one dia cakap your Dn, the decay rate, inversely proportional to the number of nuclei. So maksudnya nak cakap, kalau makin banyak kamu punya number of nuclei, okay, number of particle present kat dalam you punya atom tu kan, okay, elemen tu, so lagi banyak dia merebut untuk dia jadi lagi stable lah. So let's say lah, we have 1,500, so obviously this one will emit, akan decay lagi banyak lah in order it to become stable. Okay, so that is what decay law say. So we have a proportionality, so kita kemudian akan ada a proper equation, okay, iaitu the decay rate is equals to negative. So this one, dia ada simbol lambda, tapi nama dia adalah a decay constant. Okay, so decay constant ni adalah constant and it depends on the element ataupun particle tu lah. Okay, so berbeza-beza lah untuk setiap elemen yang ada dekat dalam periodic table tu, depends on the particle and then darab dengan the number of nuclei. Okay, so why we have a negative sign over here? So negative maksudnya indicates that dia mengalami proses decay lah. So this value of n will always be decreasing. Okay, so that's we call as a decay rate punya equation. So this one we call as decay rate. Decay rate, kadar perebutan dia. Okay, this one is number of nuclei yang ada. Okay, and then we are talking about the unit pula. So the unit will be decay per, nama pun kadar kan, jadi mesti ada kaitan dengan masa. So decay per second. Okay, number of nuclei is number of nuclei lah, so berapa banyak number nuclei ada, and the decay constants unit will be as negative 1. Okay, so itu adalah decay rate. And then we are going to talk about the activity. Okay, so activity adalah sama maksud dengan decay rate lah. So activity is also dn over dt and the equation will be the same lah. Negatif decay constant darab dengan n. Okay. So bila soalan minta activity, so we know that it always refers to the decay rate juga. Okay. But it has its own unit lah. The unit is becquerel. Okay. And then yang kat belakang ni unit dia samalah dekat atas tu. And then conclusion dia adalah we can say that one decay rate, okay, is always equals to 1 BQ lah. Okay. Because they are the same thing. Okay. So dia just nak uji you punya kefahaman nanti kalau dia nak minta activity ataupun dia nak minta decay rate, so that kamu tahu tak that they are the same thing. Okay. So maybe kamu tak tahu ke kan? So you have to know that lah. Okay. So 1 decay rate is also equals to 1 becquerel ataupun 1 BQ. So we can see that the decay rate is also equals to the activity. So when they ask activity, you use this formula lah. Okay. Because that is the only formula for activity. Okay. Alright. And then kita ada yang tu. And then okay, nama pun dia berdecay. Kalau kita pereput ni mesti akan with time kan, dengan masa kan. Okay. Jadi we have another equation, okay, that discuss relationship between your number of nuclei yang present at the moment ataupun aktiviti yang tengah berlaku, aktiviti untuk dia mereput tu with time. Okay. So kita tengok apa itu equation itu. Okay. So the equation would be dua lah, iaitu n equals to n naught, okay, e negative lambda t, or a is equals to a naught e negative lambda t lah. Okay. So this one is the initial number of nuclei. So awal-awal yang 1000 yang very unstable ni. Okay. So katakanlah dia nak pada masa 10 years kan, in 10 years time berapakah n kamu yang tinggal lah. Could be only 50 from 1000. Okay. So that is the uses of the equation lah. So sama juga macam activity. So we have the initial activity and then we can know the current activity. Okay. Katalah we want tak kisahlah apa-apa masa you nak, and then you can know the activity at that current time. Okay. And then this one, the decay constant depends on the particle or the element. Okay. So it depends, dia ada banyak value lah, depends on the particle or the elements. Okay. So why we use the exponential equation? Because we know that eventually your number of nuclei will decrease with time. Okay. That's why when we plot a graph of n against time ataupun activity against time. Okay. So let's say lah we have n or time. Okay, you remember exponential, this per tu graph, you will obtain something like this lah. Decrease with time. Let's say lah, kamu ada awal-awal ada banyak, okay, lepas tu dia akan slowly decrease, okay, until it become stable, okay. So sama juga activity, you will always get a graph like this lah. Okay, sama juga activity mungkin pada awal dia very active because it needs to get rid of many nuclei kan. Semakin lama you punya activity juga akan berkurang lah. So this is the initial one, so dia akan berkurang. Okay, so this one I think I need to draw it something like this. Okay, it won't become exactly 0. Okay, so it's something like this lah. Okay, mesti ada number of nuclei yang masa ni dah stable kan. So mesti ada sum of number of nuclei yang left. Okay, so this one is stable state. Okay, right. So okay, apa lagi yang kita boleh obtain? Katalah we have this kind of graph. Okay, we have time. Okay, so another thing that you can obtain from this kind of graph. Okay, let's say lah we have when it becomes half kan. Katalah we have 1000 number of nuclei awal-awal yang very unstable. Lepas tu kemudian dia jadi 500. Okay, so when we extrapolate this graph, okay, kita akan obtain a time kat sini kan, sejenis masa kat situ. We call this time as a half-life lah. Okay. So katalah this one, n0, yang n0 ni jadi over 4, which is 500 bagi 2 iaitu 250. And when we extrapolate, we get the second, 2 kali ganda half-life kita lah. Okay. Katalah this one mengambil masa 5 tahun. So this one maybe 10 years time. Contohnya macam tu lah. So which brings us next to the thing that we want to learn adalah half-life. Okay. So half-life is literally time taken for your number of nuclei, for number of nuclei to become half, okay? So, kenapa kita kena ada kuantiti half-life ni? Supaya kita punya pengiraan tu lagi, lagi organized lah. So, we can just say that, oh, this particle takes 3 half-life to become more stable. Instead of you just stating berapa masa dia, okay, you just can say 3 half-life lah. So, essentially, as an quantity that makes your calculation more organized lah, okay? So, selain daripada graph, we can also calculate the half-life using an equation. So, T half-life is equals to ln 2 over lambda lah, where lambda is the decay constant, okay? So, remember unit untuk decay constant tadi adalah S-1. So, you can conclude that the unit for half-life is second lah. So, I prefer that you use the decay constant and half-life ni kalau boleh dalam per second or second lah. Sebab sometimes the question will give you in hours or years, okay? So it's best that you convert all the times tu kepada second, kan? So let's say lah you have 40 years, kan? Okay, 40 years. So kalau boleh bila nak masuk dalam equation tu, you put it in unit second lah, kan? Let's say lah, so how to convert years to second, okay? So we know that 40 years ada 365 hari, and then satu hari ada 24 jam, and then satu jam ada 60 minit, and then satu minit ada 60 saat lah. And then you will obtain your answer in second. Okay, so this topic is very simple. You just use the formula. So kita akan tengok a couple of examples to see where can we use the formula. Okay, thank you.